All right, so the next bit we're going to get onto is the phases 3 through 5 are the interaction system. Our Uber producer has come down and said, I want you guys to make me an interaction system. And that interaction system, we need to create an interaction system that allows the player to interact with the game, change the game state. For example, collecting the coin. It would remove it from the scene, and the game would know that the coin has been collected. So when we're testing further conditions, we can just check a very simple state and say, has the coin been collected, yes or no? We want to create a system where the player must click on interactable game objects in the scene, and based on conditions in the current game state, trigger a series of required reactions. The interaction system must support all interaction in the game apart from player movement. We've got the player movement already down for the on-ground click, but all of the rest of the interaction in the game, we want to see if we can lump into one system. We got together, sat down, all of us, talked it out, did some whiteboarding, and we've come up with an approach. We're going to create an interactable game object, and that game object will receive user click input as an on-click event, and we'll use the event system, and based on a set of conditions, we'll call a series of reactions. The interactable game object will be standalone, and it's going to hold all of the logic and events, and it's going to be decoupled from any actual props in the scene. For example, the coin or the painting won't be an interactable, but there will be an interactable game object with a collider that we can set around the coin or we can set around the painting that will then do the interaction, so that we separate our interactables, we separate that from the actual props that we have. Two different things. Let the art department do the props and let our system work for the interactables. An interactable game object will have a collider to detect clicks. We'll use an event trigger to process the clicks, and an interactable component which we will write, will be used to control the logic of the interaction. So the player moves to the interactable. We click on the interactable. The condition collection will have a series of conditions, and we check to see if they're all correct. And if they're not, well, then we move on to another condition collection and see if those are correct. And if the new condition collection is correct, then we call a reaction collection, because we want to be able to do more than one reaction. We want to have a collection of reactions, an animation reaction, text reaction, anything that we need in the game. So conditions. The conditions we are going to make are data objects that only contain an identifier and a Boolean state. So a simple data objects, and they're going to be saved as scriptable objects. And these are scriptable object assets that can be used to compare the state of a condition. Now we're going to have reactions. And reactions, they can be a whole bunch of different things. Playing animations, setting and displaying text, loading scenes. And so if we're playing animations, they can be an animation reaction, we can have a text reaction, we can have a scene reaction, and so we're going to use inheritance and polymorphism to create these specific reactions for each possible type of reaction. Now, these reactions are going to be encapsulated. So James, can you tell me about encapsulation?
Well, each interactable doesn't need to know about what reactions it's going to play. All it needs to know is that there are reactions, and it should play them under the specific circumstances. So we're going to have a separate separate component called a reaction collection, and that's going to just have a react function, and that will distribute its information. It'll tell the scene what should happen.
So the interactable will have a single object reference to a reaction. The interactable will call a single react function, regardless of how many reactions there are. And to improve workflow, we're going to make another custom editor, a custom inspector, or custom editor that will be used to create and accommodate all of the different types of reactions, conditions, and interactables. So we're going to go into phase 3, and in phase 3 is just simply going to be the conditions themselves. We'll go into separate phases for reactions and the interactable game object. Narrowing it down, Specifically, the brief for conditions is we need to create a system to make our reactions, which are going to be already done in this, we need to make them conditional. So our approach is that all conditions are going to be scriptable objects. Some conditions will be saved as assets that to represent the global state of the game. And some conditions are going to be scene instances in the scene, which will represent the required state. And we are going to compare these.
Our conditions are going to exist in several places, just as Adam said. We're going to have instances that exist in the scene, and those are going to be part of condition collections. And what they're going to do is we're going to compare those to other instances of conditions which exist as assets. Now, the ones in the scene, those are going to be what we require to happen for the reaction to play. And the ones that are assets are the global state of the game. So we have these two instances, and we need to compare them. So what we're going to do is compare the description to one another. Actually, that's a little bit of a lie. What we're going to do is we're going to create a hash for each of the descriptions. So instead of comparing a string to one another, we're going to create an integer based on that string, and then compare that. When we know that they match, we've found the matching condition. Once we've done that, we can check whether the satisfied condition matches. So we know we've found the condition that we want to check. Does the state of that condition match the global state of the game?
And that's, for example, you would look, if we wanted in a check to see whether the coin had been collected, we will look for, in the all conditions, in the assets, where there will be a has been collected or coin has been collected condition, and it's storing whether it has been satisfied or not. That's the global condition of the game. There will be a desired condition or required condition, which is you can't get this unless the coin has been picked up. And when the coin has been picked up, the asset, the global state, matches the desired state or required state, has been picked up, then you get your reaction, you get your coffee that you're looking for.
So the other instances of conditions that we'll see are those that are stored on reactions, because of course we want a reaction that can change the state of the game. We want to say, okay, we've just picked up the coin, now we'll change that state so that now the coin has been picked up condition is true. So we've got a condition there, and we've got an all condition, the global state. But instead of being a separate instance, it's a reference. So we're going to reference the global state of the game. And our reaction is going to have a separate satisfied state. And we'll use that to set global state of the game.
And so the example that you have in this case, the interactable around the coin, will have a reference, just an object reference, to the asset, which is the global state, whether the coiner has been picked up or not. And then when you pick up the coin, the reaction is to change the state on the asset from has not been picked up, false, to has been picked up, true. Now, these conditions will have an integer hash representing their description, rather than simply the description that has been written in. And comparing the hash is more efficient than comparing the descriptions as strings. So let's get into the steps. So we're going to be looking at the condition script. Now, this is, again, a script that we are going to show you and walk you through, so you do not need to open it. So we are going to go to scripts, and down to scriptable objects, and then we're going to go down to interaction and conditions, and we are going to open the condition script.
So this is, again, a very simple one, similar to the item script that we saw before. Again, this is a scriptable object, but this time we don't want to be able to create assets in the menu. Instead, we're going to be creating instances that exist in the scene, and then separately we'll have assets that are created for the global state. We're not going to look into that in too much detail. You can have a look at that in your own time if you would like. So there's three variables here. There's a string, which is a description, a bool, which is whether or not this condition has been satisfied, and an integer, which is the hash of the description. So we've already established what all of those things are. I just want you to see what it looks like. OK? So the next thing that we need to do is have a look at the all conditions script. So that is going to be the representation in our game of the global state. So it's going to be whether or not the player currently has the coin. It's going to be whether or not the bird has flown away, those sorts of things. So first off, if we look at the top, we can see that this is inheriting from resettable scriptable object. But we haven't actually covered what inheritance is. So let's have a quick look at that now. So if you've had a look at the intermediate scripting topics, you should be quite familiar with inheritance. So we're just going to cover this quite quickly. So to start off with, we've got a public class which we've called enemy. And this defines a humanoid, but not really a whole lot about it. We know that it's going to be a bad guy in our game, and that it's got 2 arms and 2 legs, but not much more than that. Next, we've got another public class which we've called orc. And this inherits from enemy, and that means that it's got all of the properties of an enemy, but it's also got some additional properties on top. For example, the green skin and the funky belt buckle. Next, we've got our public class called orc chieftain. This inherits from orc, so that means it's got all the things that an orc has, but it also has the hat and the axe. So in addition to this, we could have, for example, our public class goblin, and that would inherit from enemy, so it had all the things that enemy had, but this time it was different from orc. So that's another way that we could look at it. So let's have a look at that all conditions script. Okay, so all conditions is inheriting from resettable scriptable object, and that means that it has all the properties and functions of the resettable scriptable object. Now, all that does is it means that we have to have a reset function on our all conditions script, because whenever we start the game again, we don't want to keep the old state of the game. We want to reset it and start from afresh. So that's what we're going to use our reset function for. So the first thing that we've got here is a public condition array. So these are the conditions that represent the state of the game. So this contains our has coin, it contains our has fish, etc. Next, we've got a private static reference to our self. So that means that whenever we have access to the type all conditions, which we will have all the time, we can say all conditions dot instance to find the type. Now this one's private, but we have a public static instance which is a property to find this type. So let's quickly have a look at that. First off, we've got, if we don't have that instance, try and find it in memory. So it's going to say, if we don't have an instance, set the instance to find object of type, and then the all conditions. If we still don't have it, if we still have a null instance, then try and load it from the resources folder, given the load path which we've got just above that. If it still doesn't exist, then we're going to just send an error that says, hey, it looks like it hasn't been created yet, better create it. And finally, we'll return the instance. Okay, below that, we've got our reset function. Just as we were talking about, we need to make sure that the global state is reset whenever we start a new game. So if we have conditions, so if the conditions are null, then we don't need to do anything. If we don't have any conditions, then we're going to loop through all the conditions and set their satisfied bool to false. Finally, we've got a public static function which we will call check condition. So this is what we're going to use to compare to conditions that are set in the inspector in our scenes. So for example, our condition collection says we need to have the coin. We need the has coin condition to be true. So what we're first of all doing is we're caching the all conditions. Then we're creating a global condition. So this is the one that we want to compare to. Next, if we have all conditions and there exists at least one condition, then we're going to loop through all the conditions. And for each one, we're going to check if that particular condition has the same hash as the required condition that we're looking for. If it has the same hash as the one we're looking for, then that is the global condition that we want to check. After that if statement, after that loop, we've got if we don't have the global condition, if we didn't find a matching condition, then obviously we can't have that condition being true, so obviously this is going to be false. There's no condition to match to, then the condition definitely isn't met. However, if we did manage to find the global condition, then we need to compare the two satisfied bools. If the condition says, I need this condition to be true, and the global state is true, then that's going to return true. If they're different, then it's going to return false. And that's all there is to the all conditions script.
We're now going to take a look at the condition collection script. So going back to our scripts, we want to grab the condition collection script. In this case, we want you to be able to edit it. So this is something that we're going to work on. We've taken a look at all conditions and condition. So now we need to edit the condition collection script.
So remember, this is the object that exists on an interactable. An interactable has an array of condition collections. Each condition collection has an array of conditions. A condition collection also must have a reference to the reaction collection that it wants to play should all of its conditions be satisfied. So let's go through and make those variables that we need. We're going to have an additional variable here, and this is not used for any computation or anything. This is just used to make it easier to see what's going on in the inspector. So we're going to create a public string, which we will call description. So that's just going to be something that appears in the inspector so that we know what this condition collection is about. So it might be something like has glasses and has coffee for the guard, for example. Next, the most important part of a condition collection is the array of conditions that belong to it. So we're going to say public condition array. And we'll call those required conditions. And we're going to give this a default value. And that default value is an empty array. So we're going to say new condition array of size 0. So the reason that we do this is whenever we're dealing with our editors for various things, if something has an array and it isn't set automatically, then we might have to check for null. And by doing this, the only time that it could possibly be null is if we set it to be so. And if we don't want to set it to be so, then it's never going to be null, so we don't have to worry about it. The last variable that we need is the reaction collection that will play should all the conditions be met. So we're going to create a public reaction collection, and we'll call that reaction collection. So now we've got all our variables. There's only one function that we need to do, and it's already got a stub there. We need to check the conditions and react if necessary. By default, this is going to return true, but we need to add a bit more meat to it. First of all, we need to loop through all of our conditions. So we're going to create a for loop at the start of this function. And that's going to loop between 0 and the length of the required conditions array. So required conditions dot length. Now for each condition, we're going to call that all conditions function that we looked at. And we only care if the condition is not met. If the condition is not met, then we want to return false and do nothing else in this function. If it is met, then we want to let it continue going on until it finds one that isn't. So what we're going to say is if not all conditions dot check condition, and the condition we're checking is required conditions I. We're going through each condition, we're checking it versus the all conditions version, and if it's not met, then we're going to return false. However, if we manage to get all the way through this loop and we haven't quit, we haven't returned false at any point, that means that all the conditions have been met. And if that's the case, then we should react. So we're going to say, if there is a reaction collection, then call reaction collection dot react. Finally, since we have reacted, we're going to return true, and that's what's already been left in our stub. That's all there is to condition collections. Very, very simple. And it's actually part of one of the principles that we wanted to address here is we're making our editor scripts a little bit more complicated. We're putting a little bit more effort into that so that all the runtime scripts can be as simple as possible. All it's got is it's got an array of scriptable objects that it's checking through. OK, save your script and return to the editor.
So we're now going to talk about the editor with sub-editor script. Now, this is a custom editor, or it's going to be the base of a custom editor?
So as I was just mentioning, the condition collection is a very, very simple script. But in order for us to have such a simple script, we need to have a bit of backing. We need to make sure that each of the scriptable objects that we're putting in those condition arrays are correct. And in order to do that, we need a bit more of a complicated editor script. Also, remember we've got this hierarchy where we've got an interactable, which has an array of condition collections, which has an array of conditions. So normally when you create an editor, you create it for the parent type. So we would create an editor for our interactable. But we also need editors for our condition collections. We need to be able to see those as well. We don't want those to just be object fields. We want to be able to see what's going on in our condition collections. What's more, we also want to be able to see what's going on in our conditions. We want to have a drop-down so we can select which condition we want. So each of our editors might need some sub-editors. And it turns out that's actually going to be something that happens quite a lot in this game. So we're going to make a base class that does a lot of the functionality for us. So remember, we've got interactables, and they have condition collections. Condition collections have conditions. So our interactable editor is going to have condition collection editors as sub-editors. Our condition collection editors are going to have condition editors as sub-editors. So what we're doing is we're going to make a well, we've already made the class for you, so you don't need to worry about it, but we're going to run through how that class works. So we're going to find that in scripts editor abstracts. So I'm going to slow down again a little bit here because this is quite a complicated script. This is one of the most complicated ones in the project. OK, so first off, it is an editor. So we're going to be using the editor namespace. That's at the very top of the script there. Next, notice the keyword abstract when we're declaring this class. Now, an abstract class is one that cannot be instantiated by itself. So it doesn't make sense to just make an editor with sub-editors. You need to give it a context. What is this an editor for? What are the sub-editors for? Well, this definition doesn't contain anything for that. This is just a base class. So we don't want to be able to instantiate this. We want classes to have to inherit from this and then be instantiated. Next, we've got the name, editor with sub-editors, nothing unusual there. But afterwards, we've got these angle brackets. And those are generic types for this class. Now, I'm sure most of you here will have come across generics, even if you're not aware of it. If you've used the getComponent function before, that is a generic function. You have to give it a type within those angle brackets. And you can do exactly the same here with a class. Rather than giving it a type as a function, we're giving our function types. So as I was saying, editor with sub-editor, it doesn't make sense by itself. We need to know what it's targeting. We need to know what those sub-editors are going to be. So we're going to give it a type for the type of sub-editor. So that's tEditor. That's going to be, for example, let's say we're using this for our condition collection editor. We need sub-editors which are of type condition editor. So that's going to be what we put in there. Now we've got the tTarget, the type of the target, and that's going to be the target of those sub-editors. So remember, we've got condition collection, that has conditions in it. We've got condition collection editor, that has condition editors as its sub-editors, and the target of those is conditions. So just below that, we've got some sentences which start where. Now, where is a restriction on a generic type. So in our case, we've said where tEditor inherits from editor. So whenever someone is trying to use editor with sub-editors, and they give it a type, this class will make sure that the type that it gives as tEditor is an editor. It needs to be something that inherits from the editor class. The next restriction we've got is on tTarget, and that's for an object. So Unity editors can only target Unity objects, so we're making sure that the target that we give it is also a Unity object. So now we can see how those types are being used. We have a protected tEditor array. So that's an array of the sub-editors. So in our condition collection example, those tEditors would have a type of condition editor, because the condition collection editor needs an array of condition editors. Next, we've got the check and create sub-editors function. So rather than in each inheriting class having to worry about when we create the sub-editors, do we need any more, we're going to put that in a function here that the inheriting class just needs to call appropriately. So we need to give it the array that it's going to be targeting. So it's got that tTarget array sub-editor targets as a parameter. So again, in our condition collection example, that's going to be the array of conditions on the condition collection. Then it'll know how many it needs to create, whether it already has the appropriate number, etc. So within the function, we've got an if statement. Now, if the sub-editors are not equal to null and they have the right number, then we know we have editors for all of the targets. So we don't need to do anything else, and we can return. However, if the sub-editors are null or they are not the correct amount, then we need to do something. So what we're going to do first is make sure that the old editors are all gone. We're going to clean them up. We're going to get rid of them. Then after that, we're going to create a new array of editors. And the number of editors that we need is however many targets we have. Now, once we've created that new array, we need to go through all of the editors in the array and actually create them. So we've got a loop here, going through all of the sub-editors array, and for each one, we're creating an editor of the given type, of that type editor, the tEditor. Finally, we've got a call to sub-editor setup. Now, if we scroll down to the bottom of the script, we can see that that's a protected abstract function at the very bottom there. So what that means is, since it's abstract, it doesn't exist in this class. It needs to be created in inheriting classes. Because it's abstract, it needs to be created. The inheriting classes are forced to create this. And then it's used when they are created. So just like a constructor would be, you create something, and then you do a little bit of setup with it. That's what this function is for. Next, we've got the cleanup editors function. And that simply checks if there are sub-editors. If they're already null, then we don't need to do anything. Just get rid of, just exit the function. If they're not null, however, we need to loop through them all, and we're going to call destroy immediate. So that means we're going to destroy every single editor. Destroy immediate works slightly differently than destroy in that it's used in the editor. Destroy is generally used just with scene objects. And finally, we're going to null out the array.
This is sort of more of a graphic representation of what we're doing here.
Yeah. So this is a representation of what we were talking about. So we've got our interactable, and that has an array of condition collections. So our interactable editor, the serialized object points to the interactable, and then it has an array of sub-editors which target the condition collections. Next, within these sub-editors, we have condition collection editors. Now, each of those has a serialized object, and that targets the condition collection. It has an array of sub-editors which target the conditions. And each of the condition editors, their serialized object represents a condition.
Condition collection editor. So we're going to go ahead and help write the condition collection editor. Let's navigate to our scripts editor interaction conditions folder, and let's select the condition collection editor script and open it for editing. We're going to need to complete the conditions collection editor script, and we're going to be talking about serialized object again, serialized property, and the use of editor with sub-editors here.
So let's have a look at what we've got so far. Currently, what we've got is we've got a condition collection editor, and that is inheriting from editor with sub-editors. We've got a serialized property which is called the collections property. Now, I should explain that represents the condition collections. That is the serialized property which is part of the interactable editor, and it represents the condition collections array. So we need to know about that in the condition collection editor so that we can remove ourselves from that array. If we want to get rid of a condition collection, we need to know what we're getting rid of it from. Next, we've got some private serialized properties. Those represent the fields that are part of a condition collection. So we've got a description property, we've got a conditions property, and a reaction collection property. Next, we've got some constants, and we're using the same naming convention here that we did before. So our constant strings there are the names that we used in the condition collection. And we've also got some constants which are just the size of some buttons which we're going to use. OK, let's look at onEnable. We've got an if statement in there. And that if statement is saying if the target is null, so if somehow this has been created but the target doesn't exist, then we're going to destroy ourselves because we shouldn't exist. So we've got a lot of editors creating editors here, and if something happens to go wrong, it shouldn't, but if something happens to go wrong, then we're going to make sure we don't have editors left over. We're going to destroy the editors that are left behind. Next, we've got the assignment of those serialized properties. As we did before, it's all exactly the same. It's just with the different variable names. Next, we've got onDisable. So remember, we're going to be creating these sub-editors. And when we destroy this condition collection editor, we want to make sure that all of the sub-editors are destroyed as well. So we're going to clean up the editors in onDisable. We've got our sub-editor setup done. That is, once a condition editor is created, we need to make sure that the condition editor is using the appropriate type. We want to make sure that this condition is displayed as though it exists on a condition collection. And it needs to know about the conditions property. It needs to know what conditions array it belongs to so it can remove itself if required. Now we've got an empty onInspector GUI function, which we're going to fill in shortly. And we've got an expanded GUI function. So remember, we want to make this inspector as tidy as possible. So each of our condition collections is going to be displayed in a box like we did with the inventory editor, and we're going to make that collapsible. So when it's collapsed, we don't need the expanded GUI to be displayed, so we put that in a separate function. We're not going to worry about that. That just displays the parts of the condition collection. All we're worried about is how do we write this editor. So at the very bottom of the script, one more function, we've got a public static function which creates condition collections. So if you want to create a condition collection, where do you go? Well, it makes most sense to go to the editor. You go to the editor, you create the condition collection, and what does that do? Well, it needs to create condition collections, but at the time of opening this project, we didn't have condition collections, so this is looking a bit empty at the moment. We're going to need to come back and finish this off. But for now, let's go back up and make sure we've got all of the variables that we need. And we also got one missing thing. We need to know what this is targeting. So we've got a custom editor attribute to add. So at the top of the class, create an attribute called custom editor. And it's going to be targeting the type condition collection. So type of condition collection. So next, we need to tell our sub-editors about the array that they're going to make sub-editors for. So we need a reference to the target. So we're going to store a reference to the condition collection that this is targeting. So with your private variables, create a condition collection variable, which we call condition collection. So uppercase for the type, lowercase for the name. Next, we're going to go down to the onEnable function. And the first thing that we need to do is cache that condition collection, because we've got a target variable that's going to be pointing to our condition collection, but it doesn't have a type yet. It's just an object. It doesn't know what it is. So we're going to convert that target to a condition collection type and store it. So at the bottom of onEnable, we're going to have the line condition collection equals, and then in parentheses, the type condition collection, so that's capital C, condition collection, close parentheses, and then target. So that's taking target, treating it as though it's a condition collection, and storing it in our condition collection variable. Now, onEnable is called when this editor is first created, so we need to check and create those sub-editors, the ones that we need for the conditions. So after storing our condition collection, put a call to check and create sub-editors. And the sub-editors we need to create are for the required conditions array of the condition collection. So we're going to say condition collection dot required conditions. Okay, so the rest of that is all fine. Let's go down until we find something that needs completing. Just as we did before, same habit, good habit to get into. At the start of the function, serialized object.update. At the end of the function, serialized object.apply modified properties. And then we're going to put everything else in the middle. So onInspector GUI is called every frame. That means that condition collections could be added or removed during that time. So that means we might need to remake our sub-editors. As such, we're going to put a call to check and create sub-editors. Next, again, my habit is to make everything tidy, put it in a box. So we're going to use the same vertical layout group in a box that we did before. So that's editor GUI layout.begin vertical. And the parameter is going to be GUI.skin.box. And since we're beginning a vertical layout group, we need to put a call to end it. So that's editor GUI layout.end vertical. And again, since we're in a box, we want to put an indent in. So just after begin vertical, we're going to say editor GUI.indent level ++. And just before the end of the vertical layout group, we're going to say editor GUI.indent level --. OK. So what do we want first? Well, we need the foldout to determine whether we're showing the expanded GUI or not. And we're going to have that as a label as well as a foldout, and then a button at the end, because whether or not we're expanded, we want to have the button that enables people to remove this condition collection. So to do that, to make everything on one line, we're going to start a horizontal layout group. So we're going to say editor GUI layout.begin horizontal. And since we've started a horizontal layout group, let's end that as well. So that's going to be editor GUI layout.end horizontal. Now notice we're not giving this a box because we don't need this foldout to be in a box. It's already within a box. So within this horizontal layout group, we're going to show a foldout. Now we're going to use a little trick here. Serialized properties don't know what type they are talking about unless you actually question them. So they have all the properties that they could need for any type. And one of the properties that they have that we can use because it's not being used elsewhere is a property called isExpanded. So that's used for, in the editor, is this expanded? So we're going to say description property dot isExpanded. And then we're going to set that equal to editor GUI layout dot foldout. And then the foldout takes two parameters. It takes whether or not it's currently being shown. So that's, again, the description property dot isExpanded. And it needs a label as well. So we're going to say description property dot string value. OK, so that's dealt with our foldout. But again, remember, I said we need a button at the end there to determine whether or not we remove something. So after that, we're going to say if GUI layout.button. And the button, we're going to give the label remove collection. That's a string. And we're also going to give it a width. And remember, we had those constant floats which were for width. And the way we set a width for a GUI element is we say GUI layout.width. And then the width is going to be collection button width. So what happens when we press this button? What we need to happen is we need an object to be removed from the array of collections. We need one of the condition collections to be removed from that array. However, Unity doesn't actually have a straightforward way of removing a single object of a specific type from a specific array, because this is quite specific to what we're doing. So what we're going to do is we're going to make something called an extension method. Actually, more correctly, we've made an extension method, and we're going to show it to you. So what are extension methods? Well, an extension method is a way of adding to a class that's already been compiled. So for example, let's say you've got a transform, and you think there should be a function in that transform that moves it 10 units to the right. Well, Unity hasn't written a function that moves a transform 10 units to the right. You'd have to do that. But where would you put that function in your code base? Would you have it on a monobehavior? So whenever you wanted to call it, you had to have a game object with that script on, and then you give it the transform. That's a bit untidy. That's not really quite right. You could have a static function that you gave a transform, and then it moved it 10 units to the right. But again, that's a little bit messy. But if you could just say, my transform.move 10 units, that'd be very tidy. And that's what extension methods allow you to do. So we're going to have a look at how to do those now. And those are kept in a different script. That is the serialized property extension script. We have here a static class, which we've called serialized properties extensions. The name of the class is important. It's not actually going to be used anywhere, but the fact that it's static is important. We need to put all of our extension methods in a static class. Also, we need to make sure that the extension method itself is static. So let's look at the exact example that we're going to look at, the one that we're going to use. And that's the very bottom of the script. It's remove from object array. OK, so it's public, because obviously you want to call it from outside of the serialized property. It's static, and that means something different to what static normally means. In this case, what it's saying is that this belongs to that type, but that it is an instance method. Next, it's returning void. That's just part of a normal function. We've called it remove from object array. That's something that we're determining the name of. And we're going to make this a generic function. We need that to be generic for our reasons. But specifically, the extension method needs to have this first parameter here. So we're targeting serialized properties. So the first parameter in this function is a serialized property, and it has this in front of it. So that's saying, call this function from this serialized property, and we've called it the array property. Now for our specific extension method, we've given it another parameter, and that is t, the element to remove. So this is a generic type of element that can be removed from an object array. The only restriction that we have on t is that it is a unity object, because that's all that can be stored in serialized property arrays. Okay, so the first thing we do in this function is we say, well, if the array property is not an array, then throw an exception. Now, I'm pretty sure everybody in this room has had an exception at one point in their life. But in order to throw your own, you say throw and then the type of exception you want. We're going to just use a standard unity exception. And the idea is what an exception does is it delivers a message to the console, but also halts all execution of this function where the throw happens. So if the serialized property that this is called from is not an array, then we don't want to do anything more. So we're going to throw an exception saying that it's being used incorrectly and not do anything more in this function. Next, if we don't have an element to remove, if the element to remove is null, then again, we don't really want to do anything here. We don't know what to do with removing a null element from an array. So we're not supporting that. Okay, next. So our array our array property, that must be part of a serialized object. And it has a reference to the serialized object that it belongs to. Now, we want to make sure all of the information about that serialized property is up to date. So we're going to call our update method. So now we know that the serialized object is correct and all of its properties are correct as well. So that array property is now up to date. Once it's up to date, we're going to loop through all of the array elements. And we do this, instead of dot length, it's a dot array size. Next, while we're looping through this, we're going to find each serialized property element. So as we loop through, remember, the serialized property contains an array of serialized properties. So we're finding each property, which we'll call element property. Then, since this is an object array, we're saying if the element has the following object reference, the one that we've passed to the function, then remove that element at that particular index and return out of the function. However, if we've gone all the way through the loop, and we've not found that array element, then again we want to throw an exception. We want to say, hey, we didn't find that element that you were looking for, we couldn't remove it, so warning. Okay, so that is the extension method that we want to use. Let's put a call to it. So the array property that we're going to be calling it from is the collections property. So remember, we have our interactable. That has an array of condition collections. We found the property that stores those condition collections. And we're going to remove the condition collection that this editor is targeting from that array. So we're going to say condition collections dot remove from object array. So you'll remember when we saw that script, it had two parameters. It had this serialized property, and then it had an object of a specific type. Since this is an extension method, it already implicitly knows which serialized property to pass as a parameter, because that's the one it's being called from. So we only need to pass this one parameter, and that's the object that we want to remove. So the object that we want to remove is the target of this editor. So that's the condition collection that we cached earlier. OK, so that's the foldout and the button. That's all on a single line. Now, we don't want to do anything more on the same line. So we're going to do the next bit after editor GUI layout.end horizontal. If we did it before we did the end horizontal, everything would start appearing on the same line, and it would get very messy very fast. So we've got the fold out, we've got the button. Now we just need to display the rest of the GUI, which is in our expanded GUI function. So we just need to optionally put a call to that. And we only want to call it if the condition collection is expanded. And remember, we used that cheeky little shortcut and put it in the description property dot is expanded. So we're going to say if description property dot is expanded, and then we will call expanded GUI. So that's the end of the onInspector GUI function. We've only got a little bit more to do in the rest of this. And that is at the end when we're creating a new condition collection. So scroll all the way down to the bottom of the script, and you'll see that very empty-looking condition collection, create condition collection function. Now, the reason this is empty is because when we created this, we didn't know what a condition collection was going to be like. We added all of those fields ourselves just now. So let's add some defaults to those fields based on what we now know. So we created a new condition collection. We can see that. Let's set a default value for its description. So before the return line, but after it's created, we're going to say new condition collection dot description. And we're going to set that to a string of new condition collection. It doesn't need to be anything fancy. It's just something that's going to be in an inspector that people can change. Next, well, we can assume that since people are creating a condition collection, they want to have at least one condition in that. So what we're going to do is we're going to create a new required conditions array for them. So we say new condition collection dot required conditions. And we'll set that equal to a new condition array with a length of 1. So we're going to make sure that there is at least one condition, because that's the only thing that really makes sense, isn't it? OK, so we created an array with one condition element, but we haven't actually populated that element. At the moment, it's still null. So we're going to populate it. So we'll say new condition collection dot required conditions and then 0. And we'll set that equal to condition editor dot create condition. So here what we're doing is we're taking advantage of the same structure across all of our editors. So here, what we're currently editing is a static function within the editor in order to create the type that the editor is targeting. So we've got a condition collection editor. We've got a public static function for creating condition collections. Likewise, in our condition editor, we have a public static function for creating conditions. So that's what we're using there. And after that, we finish that script. So save your script and return to Unity.
So we're back in Unity, save the script, return to the Unity editor, and then we're going to go and navigate to the scenes folder in the project window and open the security room scene if we haven't done it already. And we want to select the laser grid interactable game object, and then we want to add that collection. So we'll come back to this, but let's take a look at it for real. So coming back to Unity, hopefully after it compiles that will go away. Oops.
Oh dear, we've got an error.
What have I done?
Aha. So check and create sub-editors. What does that need? That needs to know about the thing that it's making editors for. In our case, that's going to be the conditions. So we need to say condition collection dot required conditions.
And that's line 57. I don't know whether anyone followed me, because if you did, I've led you off a cliff. So condition collection editor, the one we were just in, line 57, check and create sub-editors, condition collection dot required condition. So let's save that script and come back. And woo, look at that. nice clean console.
That was totally deliberate for bug finding purposes.
Absolutely. I'm changing my layout just so that it's nice and clean. We want to navigate to the Scenes folder, which is down here. So we want to go into Scenes. We want to go into the Security Room scene, open that up. And when that's open, we want to navigate to the hierarchy, and we want to select the Laser Grid Interactable. Laser Grid Interactable game object. Let's see if we can view that. I'm going to close down some things. I may have to back out. Yeah, a little bit. On the interactable component, we want to click Add Collection. So this is the inspector that we've just created. So we can add collection. We can remove the collection if we wanted to. We want to have that added collection. And we want to set the description. So let's open that up. And we want to set the description, which was new condition collection, to laser grid off. And from the drop-down, we want to pick lasers deactivated. And we want to check the satisfied box. So what exactly are we doing here, James?
So here we've created a condition collection that we've called laser grid off, and we've given it the condition lasers deactivated. More than that, we've said play the reaction collection that we're about to give it when lasers deactivated is true, when it has happened.
And then the reaction collection that we want to have for this condition is we want to take the interactable reaction field, and we want to take the beams off reaction.
So if you scroll up to the hierarchy and find your laser grid interactable and then expand it, it should have some children. Now, one of them is a default reaction, and the other is a beams off reaction. And that's the one that we want to play with our lasers off, or laser grid off condition collection.
So sorry, I'm zoomed in just to maybe a little too much for to see all of this at once. But we want to grab that beams off reaction and grab that into the reaction collection. So let's save the scene. So the last thing we did, I just want to walk you through it, is that we went to the scenes folder in the project window, we opened the security room scene, and we selected the laser grid interactable game object. On that interactable component, we clicked Add Collection, and then we set the description of the new collection to laser grid off. Then from the drop-down, we set the condition to lasers deactivated, and we checked the satisfied box. And then we expanded the laser grid interactable, and we dragged beams off reaction. And beams off reaction is a child of the laser grid interactable from the hierarchy onto the interactable reaction field.